Lecture is about volcanoes, so we're kind of moving on from earthquakes, and then we're going to spend the next couple of lectures talking about volcanoes. Again, I realize it's a lot of information for 1 week. This would normally be 3 weeks in a regular classroom, but it does tie in nicely with plate tectonics, earthquakes, and then volcanoes. They all kind of lump together nicely, hopefully, as you'll see as we go through the lectures. So again, this would be chapter 6 if you have the textbook. So in terms of the outline of the 3 lectures that you'll have, we'll talk about earth or volcano, lava and magma. In this lecture, we'll talk about what makes lava flow fast versus lava that's more explosive. And then the next couple of lectures, we'll talk about the risks of volcanoes. So what comes out of volcanoes, what kind of stuff flows down the side of volcanoes. And then the last lecture is going to be about the types of volcanoes. So just to briefly introduce volcanoes, so it's not as many volcanoes erupting each year as we have earthquakes. So earthquakes has roughly 1 million earthquakes every single year. Volcanoes is much, much less than that. So basically 50 to 60 volcanoes erupt each year. That doesn't necessarily mean they have big catastrophic eruptions. They could be a type of volcano that just oozes out lava over time. But there's 1,500 what we call active volcanoes globally. The geologist definition of an active volcano is one that's erupted in the last 10,000 years or so. So we have about 1,500 of those globally. In terms of population, roughly 500 million people live close to volcanoes. So there are many people that are subjected to the effects of volcanoes because they live nearby a volcano. So our timeline here, our graph here is just looking from 1960 to the year 2000 and the number of active volcanoes each year. So it kind of shifts between about 50 to 70 each year. Most active volcanoes are going to be around the Ring of Fire, which is the area around the Pacific Ocean. So here is the Ring of Fire in the orange. In this map, and every dot that you see is basically a volcano. So these are volcanically active regions, and most of the world's volcanoes are going to be around the Pacific Ocean. But if you look at a map in the US, our closest volcanoes are going to be over in Alaska or Hawaii or down in Mexico. If you want to access a website and see what volcanoes are currently erupting right now, here's this link down here. You can access it, and I'll actually have you do this in one of the quizzes. You'll access it, and then a lot of these volcanoes have webcams, so you can actually look up active video or live video of these volcanoes, ones that are erupting. Just to zoom in on the U.S., we have Alaska up here on the top. So if we're looking at every red triangle on the map of Alaska, each one of those is an individual volcano. Hawaii, every single island in Hawaii is a volcanic island, and there's a couple volcanoes on the big island of Hawaii. And then in the western US, we have a whole chain of volcanoes in California, Oregon, and Washington. So why did I lump volcanoes with earthquakes and plate tectonics? It's because they're all related. So volcanism is directly tied to plate tectonics. If a tectonic plate moves, then it can lead to the creation or the formation of a volcano. So where they actually come from is that you have to have melted mantle rock. So beneath the crust, you got the mantle, or the asthenosphere, if you want to think of that part or recall that term from earlier on. So you have melted rock down in the mantle, and then that melted rock, through various forces, will get moved upward towards the surface and then erupt out of a volcano. So a lot of it happens in subduction zones. So you got 2 tectonic plates colliding. One goes underneath of the other. And as it does so, it melts, produces melted mantle rock that erupts out of a volcano. Just to clarify, I have a question down here. So what is the difference between magma and lava? Magma is underground. Lava is on the surface. They are usually the same exact thing. You just find one under the surface and one on the surface. So magma is underground and lava is on the surface. So here's a terrible way of showing that to you, kind of in joke form. So magma lamp would be underground and a lava lamp would be on the surface. Just to again reiterate the mechanism for volcanoes forming, we are showing an animation here that is a convergent boundary. So you have 2 tectonic plates that are colliding and one's going underneath of the other. And as it does so, it will melt, and then that melt will rise up to the surface and erupt out of a volcano. So that's our mechanism for driving tectonic plate movement. That's our mechanism for creating volcanoes in the first place. So, if we want to know if a volcano is going to be explosive or if it's going to just be like more flowy, magma differs and lava differs, and it has different properties depending on what type of volcano is erupting material. And we'll get to that a little bit later. But in order to understand how a volcano erupts and what kind of factors or properties affect how a volcano erupts, we have to understand something called viscosity. So magma's viscosity is a resistance to flow. So if something is a high viscosity, it does not like to flow at all. It's usually very sticky. It will stay put, and that's got a high viscosity. If something has a low viscosity, it has low resistance to flow. So that means that it likes to flow. It spreads out pretty easily. So a good analogy for that is that if you have a bottle of water and you took that bottle of water and you poured it out, it will spread out very easily. And the reason for that is because it doesn't resist flow. So it's got a low viscosity because it will just spill everywhere. Let's say instead of a bottle of water, you had a jar of peanut butter. Take that, turn it over. It's going to flow out slower than the water because it's more resistant to flow. So it will have a higher viscosity. Rock we can rank in terms of its viscosity as well. And lava we can rank in terms of its viscosity, but just to give you kind of some everyday items here. So if you got water, that has a low viscosity because it spreads out easily. But if you work your way over to peanut butter, slightly higher viscosity, more sticky. But we can also look at different types of lava. They can also have viscosities associated with them as well. All right, so at this point, you should be able to complete question 1 on the quiz. Feel free to pause and then come back when you have completed that question. All right, so if we're looking at our question here, so if you have a jar of honey at room temperature and a second jar of honey that you heated in the microwave, do the viscosities differ? So your answer here is yes. If you took that honey and you heat it up, you're going to make it flow out faster because that hotter temperature material or product, food product, is now flowing faster. So if you heat something up, the warmer something is, the easier it flows. So it has a lower viscosity. So by heating something up, increasing temperature, you drop viscosity or you lower viscosity. So warmer things flow easier, raise temperature, lower viscosity. So that can be the difference between different types of lava. So this is a lava called Pahoehoe lava, this picture up here on the top. On the bottom, this is another kind of lava called A'a lava. If we were physically in class, I could show you samples of each of these. But the difference between these is that the Pahoehoe lava on the top, it flows faster because it erupts at a higher temperature. The one on the bottom, it's more blocky because it erupts at a lower temperature, so it's a little bit more resistant to flow. It has a higher viscosity. So based on the viscosity and chemical composition of magma, we can have different types of magma, which we'll get to in a second. So there's basalt, andesite, and rhyolite. And the reason they differ is because they have different viscosities. They also have different chemistries. So viscosity can also be affected by chemistry. And the way for you to think about this is that if you have lava or magma, there's a lot of gases dissolved in it, which is what helps make volcanoes explosive and erupt. Some of those gases would be water vapor, so H2O, carbon dioxide, CO2, and then sulfur dioxide is SO2. So the higher amount of gases that you have in magma, the more explosive it tends to be, and the higher viscosity it tends to have. So gases basically make a volcano more explosive and more eruptive. Just to give you an example, if you have a lot of gases in a volcano, it kind of acts like a shaken can of soda. So it's under a lot of pressure. It's got a lot of gases, CO2 in it. And then as soon as the volcano erupts, that gas gets pushed out of that volcano and makes it slightly more explosive, just like if you shook a can of soda. So the point here basically is that if you have more gases dissolved in magma, the more explosive a volcano is because it is more viscous. So it doesn't like to flow, it's more likely to explode. So here's the names of the different types of magma that can form from a volcano. So if magma or lava spills out onto the surface and it cools down, if it is dark in color, it's called basalt. So you take this lava that has flowed out over the surface and cool that into a solid rock. We call that rock basalt. That's a low viscosity, so it's low temperature, low gas content, and it flows easily. An intermediate viscosity is something that we call andesite. The root of andesite is Andes, as in Andes Mountains. So you get andesite in the Andes Mountains, and it's gray in color, and it's got an intermediate viscosity. So it's slightly explosive, but it can still flow a little bit. So most volcanoes that erupt andesite, the lava will travel maybe a half mile or so from the top of the volcano, whereas if you have one like basalt, it could travel 5-10 miles away from the volcano. Our last one here is rhyolite, so this is all the way on the right side. Rhyolite has the highest viscosity, so it's kind of the stickiest lava. It is the most explosive type of lava, and it tends to be light in color, so it's usually tan, pink, or white is the type of volcano or the type of magma rock, type of rock that it turns into when a volcano erupts. All right, so sorry I just stumbled through all that, but you can complete questions 2 through 4 on the quiz now, and then come back when you're ready. So when we're looking at magma viscosity, we already have talked about the fact that temperature affects it. It's also affected by something that we call the silica content. Silica is Si for silicon, the element silicon, and then oxygen. So silica is a combination of silicon and oxygen. So when we're looking at rocks like basalt and andesite and rhyolite that I just went over, the higher the viscosity, the more explosive it is, the higher the silica content. So the way that you can think of this is that this is a percent here on this table. It's showing you the percent of silica in lava. So basalt has lower, andesite has intermediate, and rhyolite has high percentages of silica. And if you look at it on an atomic scale, if you're interested in the chemistry of it, a basalt, in terms of its chemistry, is a pretty simple structure. It's just a pyramid and kind of isolated pyramids. So it makes lava less sticky, makes it more runny. But as you increase the complexity of the chemical bonds in lava, you basically can create a very complex structure. That complex structure makes lava sticky. Sticky lava is viscous lava, and viscous lava is more explosive lava. So the higher the silica content, the more viscous lava is, the more explosive it is. Just to give you an example, so let's say you have a funnel and you have a jar of peas, and then you have a jar of cooked spaghetti. So if you're looking at the jar of peas and you take that jar of peas and try to put it down the funnel, it's going to flow through that funnel easier because it is more simple. It's got a simple structure. So that would be like a low silica, basalt, low viscosity, something that flows and moves easily. On the other side, if you take that spaghetti and you try to shove that spaghetti down the funnel, it's just going to get stuck because it has a more complex structure. The more complex it is, the more silica it has. So it has a higher viscosity, which means it's hard to shove it through that funnel, and it's going to form something like the rock rhyolite. So to put it all together, if something is highly viscous, then you're going to get a super explosive volcano. It'll have big ash clouds that will come spewing out of it. And it's kind of like taking a milkshake and then blowing bubbles into a milkshake. You can make it more explosive. So high viscosity equals a very explosive volcano. If something is low viscosity or less viscous, it's going to have more lava flows that will kind of ooze out and have runny, flowy lava. And that's more like trying to blow bubbles into water. It's not as viscous, it's not as explosive. So if we kind of bring it back to plate tectonics, where do these different types of lava form? So basalt is what the ocean floor is made of. The ocean floor is a dark iron and magnesium rich lava that formed when two plates are diverging at a mid-ocean ridge. So if you have a mid-ocean ridge here, As those two tectonic plates are diverging, lava or magma spills out onto the ocean floor through the mechanisms that we already talked about, and then basalt will form on the ocean floor. So the ocean floor is dark in color, and it's low viscosity made from lava flows over millions of years. The other one, andesite, the intermediate one that's gray in color, andesite will form when you have a tectonic plate converging, an ocean converging with a continent, and the ocean goes underneath of the continent, and then volcanoes will form on the continent. So our example is the Andes Mountains. The Andes Mountains is where andesite forms. Lastly, we can get rhyolite if you have some of the continental crust melting. Continental crust is usually made of granite. We'll talk about rocks next week, but it's usually made of granite. If granite melts, granite tends to be really high in silica, so it will make a very explosive volcano. All right, so bad joke time. I keep ending these lectures with a bad joke. So what do you call a cute volcano? You call it lavable. All right, so at this point, you should be able to complete the quiz, and then you'll have 2 more lectures to watch for volcanoes.